Okay, so yesterday we talked about different parts of the circle, how to name it and whatnot. Today we're going to talk about some different angles and arcs that are formed within the circle. Okay, um, and the first thing we want to talk about is the central angle. And the central angle is the angle whose vertex is at the center of the circle and its sides contain the radii of the circle. So it's a central angle, so its vertex is at the center. That's an easy way to remember that. These angles 1, 2, and 3 are all central angles because their vertex is at the center, and then the sides of the angles are radii of the circle. So they're all the same length, okay? They all intersect at the center and create those central angles. If you were to add all the central angles up, it would equal 360 degrees, okay? Because there's 360 degrees in a circle. 1 degree is 1/360th of a circle. Okay? And so if I added angle 1, angle 2, and angle 3 together, it would equal 360 degrees. So with that in mind, let's find the value of x. What should we do to find the value of x? Okay, add 90 and 130 plus the one I don't know, x, right? And what's it going to be equal to? 360, right? And if I add these together, it's 220 plus x equals 360. Subtract that, and x is going to be 140 degrees. Okay, now the next thing I want to talk about is what an arc is. An arc is part of a circle defined by two endpoints. So this right here is an arc, okay? It's part of a circle. It's defined by two endpoints. When you name it, you use those two endpoints and you put a little mini arc on top of it, okay? That's basically what you do. But there's really three types of arcs. Sometimes you have to name a little bit differently, so we're going to talk about how you name different types of arcs. So that's kind of the generic thing that you do. There's minor arc, there's a major arc, and there's a semicircle, okay? And a minor arc is an arc that is less than 180 degrees. It's less than half the circle, okay? And so this right here is a minor arc. And again, you use the endpoints to name it. So this would be arc AC, and you put a little mini arc on top of it. Now, arcs have measures just like angles do. They're measured in degrees, okay? And so the measure of an arc is equal to the measure of its central angle. So if its central angle is 110 degrees, then the arc is also going to be 110 degrees. That's your minor arc. Now, your major arc is greater than 180. It's bigger than half the circle, okay? And when you name it, you can't just use ED because this right here is your major arc, okay? It's greater than 180. And so if I name that arc ED, you would think I was talking about this little part, wouldn't you? So what you have to do is use 3 letters to give it direction, all right? And so you would still use the 2 endpoints, but then you have to use the point in between. So when you name this arc, you would name it DFE, and you would still put a little mini arc on top of it. And you could go in the opposite direction. EFD would work also, okay? Now, to find the measure of the central angle, we know that this angle here is 60, so this is 60. This is the rest of the circle, okay? So you could add its pieces up, or you could do 360 minus what that little minor arc is, and that would give you the measure of your major arc. Sometimes you know all the pieces and you can add them together, but if you don't, then you can do that. Then the third type of arc is the semicircle, and that's basically half of your circle. It measures 180 degrees. But just like the major arc, if I said arc JL, would you know which semicircle I was talking about? No. So, like, if I was going to talk about this semicircle, I would have to put a point in between. So I would have to name this arc JKL and put a little mini arc on top of it. If I wanted to talk about the other semicircle, again, I'd have to put the letter in between, so it would be arc JML with a little mini arc on top of it. And your semicircles always measure 180 degrees because it's half the circle. And your semicircles are created by the diameter, okay? All right, any questions on that before we go on? Okay. All right, so we have a theorem here. It says, in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. Okay, so what this means is that within a circle, okay, if you have two central angles that are equal, then that's telling us that the two arcs that they create are going to be equal also, okay, and vice versa. If the two arcs are congruent, then the two central angles that create them are going to be congruent. Okay. Now this works within a single circle. It also works if you're comparing two circles. For example, I'm going to duplicate this real quick. Okay, so here is the same circle. These two circles are congruent. They have the same radius. So if in this circle right here, if this angle is 35 degrees, and I come over here and this angle is 35 degrees, those two angles are congruent within congruent circles. Then those two arcs are also going to be congruent. So since these are both 35, then these two arcs would be congruent. Does that make sense? So it's true within the circle and within congruent circles. Okay. All right, now, adjacent arcs. Adjacent arcs are kind of like adjacent angles. They're right next to each other. Adjacent angles share a ray or a side. Adjacent arcs only share a point. So, like this arc here and this arc here are adjacent because they share this point C. That's the only thing that they share. So that's considered adjacent arcs. And we have the arc addition postulate, just like we have the segment addition postulate and the angle addition postulate. And basically, it says that if you add two adjacent arcs together, then it's equal to the whole big part of the arc. For example, if I took the measure of arc PQ and the measure of arc QR, if I added them together, it would be equal to the measure of the entire thing. Now, when you talk about the measure of the arc, use a little m in front, just like you do in angles. So the measure of arc PQ plus the measure of arc QR equals the measure of arc PQR. And I got to use three letters because now it becomes a major arc. Okay? That's how you talk about the measure of an arc. When you're just naming the arc, you just, name it arc CD. But when you're talking about the measure, you put the little m in front of it. Okay. Okay, in circle F, the measure of angle DFA is 50, and CF is perpendicular to FB. Find the measure. All right, so we want to find BE first. We want to find this little arc right here. What can we do? Do we know anything about this circle? Anything about the angles or anything? I've got vertical angles, don't I? So aren't both of these 50? Okay, so if this angle BFE is 50, then what's BE going to be? 50 degrees. Okay, what about CBE? This time I want CBE. Okay, since this is 50, this is 90 because there's a right angle here. I would add 90 and 50 together, and that would be 140 degrees. Good. All right, what about ACE? ACE, all that. Okay, Okay, so that's 40, which means this is 50, this is 40, 90, and 50. So we could add all those together. Okay, so we get 50 plus 40 plus 90 plus 50. What is that going to be? 190 plus 40 is 230? 230, everybody agree? Now, tell me this. Could I have recognized this as a semicircle, which is 180 plus 50? Could I have done that? I could have done that too. Is that what you did? Okay, yeah. So either way, I mean, lots of different ways you can do it. All right. This graph shows the percent of each type of bicycle sold in the United States in 2001. Find the measurement of the central angle representing each category. All right, so we have a circle, and it's broken up into different, pie pieces, and it tells you the percentage. But if we were actually going to create the graph, we would need to know the degrees that would represent that. Okay, so that's what I want you to find is the measure of the central angle. All right, and so if we started out with other, how many degrees are in a circle? 360, and this is 7% of that. Okay, so what we're doing is we are finding 7% of 360. Now, there's a lot of different ways you could do this. Okay, a lot of teachers do proportions. Okay, and that may be what you're comfortable with. And so you would do 7 out of 100 equals x out of 360, and that would give you the degrees. Okay. I tend to like to do things a little quicker, like with my calculator, because you're wanting 7% of 360. Now, there's two different things you could do here. I've always changed the percent to a decimal, which means you move it 2 places to the right. You get 0.07, and then of means times 360. And that's all you have to do is type that into your calculator. Some people move the decimal on the 360 instead of the 7, and they do 7 times 3.6. That's in essence doing the exact same thing, okay? So whichever way that you want to do it, it works, okay? This is just kind of how I was always taught, but some people think this multiplication is easier, so whatever your preference is. Okay, so if I do that, what do I get? 25.2, right? Okay, 25.2 degrees is what we would use for other. Okay, how about hybrid? What do you get for hybrid? Why don't you work these out real quick? Let's see what you get. Excuse me. Okay, so we got 32.4 for hybrid, 75.6 for comfort, 93.6 for youth, and 133.2 for mountain. Did everybody get that? Okay, now, what should be true about the sum of all of these degrees? It should be really close to 360, right? We did a little rounding, so it could be a tenth or two off, but it should be really close to 360 degrees. Okay, so the last thing we want to talk about is arc length. Okay, I want you to put a big star by this. You have to know how to do this, okay? Now, yesterday we talked about a circumference, right? And the circumference is the distance around a circle, correct? And I even showed you this little wheel thing, and I said, okay, one rotation is the circumference of the circle till it clicks, right? Okay? Well, arc length is a part of that, okay? Arcs have a measure, which is a degree, and it's equal to the central angle, right? But it also has a length, which is in centimeters, inches, feet, whatever the unit of measure is in. So let's say that I wanted to start at one take and go to the next. Okay, and I want to figure out what that arc length is. Okay, well, I go from one to the other, and it ends up being 58 centimeters. Okay, that is part of the circumference. It's not the whole circumference, it's part of it. And that is called arc length. Okay, to find arc length, you have to use this proportion. Okay, and it's part to whole, part to whole. All right. You take the length of the arc is to the circumference because that's part of the circumference. And then you take the measure of the arc in degrees is to 360 because it's part of the circle, okay, part of the measure of the circle. All right? So the length to the circumference, the measure of the arc to 360. All right? That's what you do. Okay, so in circle P, it says that PR is 15. It says the measure of QPR is 120, and we want to find the length of QR. Okay, the length of arc QR. Okay. All right. So the length of the arc is unknown. Okay, that's my x. I need the circumference, and I want to keep it exact. I don't want to find the circumference and round it because then I have to round again, and the more I round, the further away from the answer that I get. So I want the exact circumference. All right. It says that my radius is 15, which means my diameter is what? 30, which means my circumference is 30 pi. Right. So x over 30 pi, okay, now I need the measure of the arc. The measure of the angle, the central angle is 120. What's the measure of the arc? 120, right? So then it would be 120 over 360. Now, sometimes they ask for an exact answer. Sometimes they ask for rounded to the nearest hundredth or something like that. So you need to be prepared to give both answers. And so we are going to cross multiply, so we get 360x equals, and this would be 3600 pi. We want to get x by itself, and so we divide both sides by 360, and we end up with 10 pi units. Okay, so that arc length is 10 pi units, yes. You could have. Yes, you could have. Just make sure when you're cross multiplying, you only reduce up and down. Don't go diagonal. Okay, only up and down. You're right. You could have reduced this. What would have been 1/3? Yes, absolutely, you could have. Okay. All right. So this right here would be my exact answer. And then if I plug this into my calculator and got my estimate, it would be what? 31.4 units. And that is an estimate. What he was saying is you could have reduced this right here to 1/3 and then cross multiplied, and that's fine, as long as you reduce with the numerator and the denominator on the same side of the equation. Okay. All right, any questions? Don't forget about this arc length, okay? Don't forget about it because you've got to know how to do this. There'll be 1 or 2 problems on your test or quiz on how to do arc length, okay? Arc length is in inches, feet, miles, whatever. Arc measure is in degrees, okay? And it's equal to the central angle. All right, your assignment is on page 710.